In this lesson, you will learn how to identify the relationships between two lines or planes and name angles formed by a pair of lines in a transversal. How are parallel lines and planes used in architecture? Frank Lloyd Wright, who has a house in my hometown of McCook, designed many buildings using basic shapes, lines, and planes. His building at the right has several examples of parallel lines, parallel planes, and skew lines. So we have here, these lines are parallel, they never cross. A skew line is not even in the same plane at all, so this line right here would be skewed to the green ones because it wouldn't be at all in the same plane. And planes, so the roof would be parallel to the floor, or this plane of this wall would be parallel to this plane of wall. Here's a different picture of Frank Lloyd Wright's Sutton House, designed by one of America's most influential and visionary architects, 602 Norris Avenue in McCook, Nebraska. It's one of the few homes west of the Mississippi, designed by the internationally renowned architect, Frank Lloyd Wright. Oh, enough for advertising for my hometown. Go Bison. Back to geometry. Relationships between lines and planes. Lines L and M are coplanar because they line the same plane. If the lines were extended indefinitely, they would not intersect. Coplanar lines that do not intersect are called parallel lines. Segments and rays contained within parallel lines are also parallel. The symbol parallel means it's parallel to. Arrows are used in diagrams to indicate that lines are parallel. In the figure, the arrows indicate that line PQ is parallel to line RS. Similarly, two planes can intersect or be parallel. In the photograph above, the roofs of each level are contained in parallel planes. The walls and floor of each level lie in intersecting planes. So the symbol parallel with a slash through it means is not parallel to, just like we're used to seeing equals with a slash through it means is not equal to. Segments AE and GF do not intersect. These segments are not parallel since they do not lie in the same plane. Lines that do not intersect and are not parallel are called skew lines. Segments and rays contained in skew lines are also skew. There are a bunch of other examples of skew lines in the diagram as well. We could look at, if we looked at DH would be skew with CB. DH would not be skew with BF because you could have a plane that could go through DBFH. So it has to be, even though there's not a plane drawn in, it cannot be drawn in to be a skew line. Name all planes that are parallel to plane AEF. Well, all makes it sound like it's going to be a long list. It's not. We've got AEF here, so they named 3 points around the plane, so that's the left side. So parallel to the left side of this box or cube would be the right side. We could call it plane BHG is one way you can name it. You only need 3 points on a plane to name it. Name all segments that intersect segment AF. Okay, AF is there on the top, so we're going to have the other two that intersect it from the top and the two that intersect it from the side. So we've got EF from the side, GF from the top, AB from the top, and AD from that left side. Segments parallel to segment DC, we've got from the top on that side, then we'll have EH and FG. Segments skew to AD. Okay, AD is here, so we need them not to be in the same plane at all with AD. So AD is going up and down, so I want things that are going right and left, so like FG, and then look for things that are parallel to FG. So I've got FG, we said, and that would be parallel to EH. We could also use GB would also be skew, and so parallel to GB would be HC. GB, HC. And then they've also drawn in a segment from E to C. So skew lines, like parallel lines, also don't cross, but they don't cross because they're not even contained in the same plane. In the drawing of railroad crossing, notice that the tracks represented by line T intersect the sides of the road represented by lines M and N. A line that intersects two or more lines in a plane at different points is called a transversal. Now, the sides of the road are parallel lines, but a transversal just intersects two other lines. They don't necessarily have to be parallel. Some of a bus station's driveways are shown. Identify the sets of lines to which V is a transversal. Now they made it a little bit tricky because they didn't extend their lines. We could make them longer. So basically the only line that V is not going to be a transversal to is the one it's parallel to. So it will not be a transversal to Y. So the other lines are U, W, X, and Z. Normally I do all of the examples from the book, but I don't think we need to look at three more exactly like this one. This diagram contains a lot of vocabulary that we'll use for quite a bit, so take some time and think about it. First of all, they talk about exterior angles, interior angles. Exterior means it's on the outside, so it's on the outside of the parallel line. So angle 1 and angle 2, angle 7 and angle 8. Interior means inside. So angles 3, 4, 5, and 6. Consecutive interior angles. The word consecutive means next to. Interior means inside. So consecutive interior angles include angles 3 and 6, and 5 and 4. Instead of consecutive, alternate means switching, and exterior means outside. So alternate exterior angles are angles 1 and 7 and 2 and 8. Alternate interior angles are angles 3 and 5 and 4 and 6. Corresponding angles. Corresponding means they line up. So in this set of angles, angle 1 is in the upper left-hand corner, so that corresponds to angle 5 is in the upper left-hand corner. Angle 2 is in the upper right-hand corner, angle 6 is in the upper right-hand corner. 2 and 6 correspond. Angle 3 is in the lower right-hand corner, and so is angle 7. And angle 4 is in the lower left-hand corner, and so is angle 8. So you can see from my overlapping diagram that different angles have different names based on what relationship we're talking about. Identify angle 7 and angle 3 as alternate interior, alternate exterior, corresponding or consecutive interior angles. Okay, angle 7 and angle 3 are both in the lower right-hand corner of their 4 angles that meet at one vertex, so they are corresponding angles. Angles 8 and 2 are on opposite sides of the transversal, so that's alternate, and they're outside, so they are alternate exterior angles. Angles 4 and 11 are also in the lower right-hand corner of their set, and so they are also corresponding angles. Angles 1 and 7 are on the outside of the lines on the opposite sides of the transversal, so that's alternate exterior. Angles 7 and 10 are on the same side of the transversal and they're next to each other, so they are consecutive interior angles. Coplanar lines that do not intersect are called parallel lines. Non-coplanar lines that do not intersect are called skew lines. When two lines are cut by a transversal, there are many angle relationships, including consecutive interior, alternate exterior, alternate interior, and corresponding angles.